All right, so when you need to do stoichiometry problems, always need to start with the balanced chemical equation. So for this one, I've got 6K plus 1N2, and that is going to produce 2K3N. So you want to take the information, start with what we give you in the problem. All right, so we're telling you that you need to convert the 12.5 moles of K. So when you write information around this chemical equation, moles should go below, because that is what the chemical equation, that's kind of the language the chemical equation is in. It's talking about relating moles to moles. So I've got 12.5 moles of K, so I'm going to put it right below the K. And I'm trying to get to moles of K3N. So here is my target, the moles of K3N. So when I go from moles to moles, I can just go straight across. All right, because again, the language of this is in moles, I don't need to translate it. Then I can just use that relationship. Right, the number of arrows you draw in this tells you how many steps the problem is. So I start with the number the problem gives me, 12.5 moles of K. And now it's going to be really important that you write the chemical symbol as to what you're talking about, because we're going to switch. So that many moles of K, that is the relationship between the moles of K and the moles of K3N comes from the balancing of that chemical equation. We call this the mole ratio or the Stoich ratio. So I know that we have 6 moles of K is going to create 2 moles of K3N. All right, and then that's all I need to do because I have one arrow, so I have one step to my problem. I need to solve that, and that's going to be in moles of K3N. So I just do that, and I get my answer. And the number I'm going to get once I run it for sig figs is 4.17. Remember, the calculator doesn't think in sig figs. The calculator is going to give you 4.16667. But because I have 3 sig figs in this first number, so then I need 3 in my answer. All right, you notice I didn't care about those for sig figs. Those are not things that are measured with an instrument. Those are identities of how these react. So I do not worry about sig figs when I'm thinking about that mole ratio or the Stoich ratio. So I have 1 significant figure to 3, so I have to round there. And because that next number is a 6, I'm going to round to 4.17. All right, let's try. I'm going to let you try example 2, and then you can check it. All right, so this should be your setup for the next problem. We're starting with moles of K. So I wrote that under the K to keep track of it. And I need to find moles of N2. So I start with the value we're given in the problem. And then I use my mole ratio or Stoich ratio between the two. For every 6 Ks that react, I need 1 N2 to react. So I can cancel out the moles of K, and I end up with getting moles of N2. Again, there's 3 sig figs in that number because we started with 3. All right, now let's go to one that's a little bit more challenging. So again, we're going to start with the same chemical equation. So I'm going to start by writing my 6K plus my N2 yields 2K3N. And I'm just going to put a 1 in front here. You don't have to, but I'm just going to put it in there just to remember that that's what it is. All right, so now the start of the problem is the grams of N2. Okay, so we'd always been putting moles below, and we're going to keep doing that. Grams, if you have a gram number, I want you to put it above. So we're starting with the 26.3 grams of N2. And then I'm ending with moles of K. So I'm going to end right down here with moles of K. So to get there, I do not have a direct path. I can never kind of go diagonal from one thing to another. So what I need to do is I need to be able to do a couple of conversions here. I need to be able to right away go to moles. All right, moles are going to be our key. Moles is the language we use to get from one part of the equation to the other. So I'm going to find the moles first. And then once I find the moles, the moles of N2, then I'm going to go find the moles of K. All right, and right away you can see this one's a little bit different. There's 2 arrows. That's going to tell us our steps. The first step I have is going to be going from grams to moles. And if you remember, the way you go from grams to moles is to use the periodic table. Then we're going to, in our second step, we go from moles of N2 to moles of K, and that's where I'm going to use those Stoich ratios. So I'm going to set the problem up starting with my 26.3 grams of N2. All right, now I need to get into moles of N2, and this is where I use the periodic table. So remember, on the periodic table, everything is related to 1 mole. So whatever the mass is on the periodic table, I need to find the molar mass of N2. And if you look, I'm going to do this off to the side, N is 14.01, but the formula I'm working with is N2, so it's 28.02 grams per mole. So I have 1 mole of N2 is equal to 28.02 grams. All right, that's going to cancel out my grams of N2. And now I'm into moles of N2. So that would be, I've just found this value. Then I need to go further because I need to end up in moles of potassium, moles of K, and I'm not there yet. So now I need to use my mole ratio, my Stoich ratio, to go from 1 mole of N2. And again, the reason it's a 1 is because there's a 1 up there, and then 6 moles of K because I've got a 6 there. So I need, for every 1 mole of N2 that reacts, I need 6 moles of K. And then I can do that math. Remember, you're multiplying across the top, dividing the bottom, and then you've got 5.63 moles of K, because again, we have something with this beginning number has 3 sig figs. This number had 4 sig figs, and I don't worry about sig figs on that mole ratio because it's not something that's measured with an instrument. All right, after that, I want you to try example 4, and then start the video up again when you are ready to see if you got it correct. All right, here we go. So again, the way I set it up, I'm starting with the moles of K3N. So I put that down below. All right, so those moles go down here. And then I go across to the moles of K, and then I can go from moles of K to grams. Again, the only way you can move from one side of this equation to the other is if you have the mole ratio. I can't go from grams to grams. It's not. I have to translate the grams into moles and then work mole to mole. All right, and we've got one more example. All right, so for this example, we're going to try a different balanced chemical equation. So we want you to go ahead and balance this. So if you want to, pause the video and then try to balance it and then start the video up again. So balancing for this, I've got 1, 2, 1, 2 in order to balance it. All right, so then I'm going to, again, I'm going to rewrite that. You don't need to. If you feel like you have enough room to not rewrite it, you don't need to rewrite it, but I'm going to. So I have a little bit more room on the top and the bottom. And, oops, wait. Hold on, just kidding. All right, here we go for example 5. So example 5, again, I have to look at the information I'm starting with. I'm starting with 45 grams of AgNO3. So again, we're going to do the same thing, gram numbers, put them above the species that they're talking about, moles go below. So I've got 45 grams of AgNO3. So I have 45 grams of this. And I need to find grams of ZnBr2. So ZnBr2 is over here. So what I can absolutely not do is just be like, oh, well, I can just do that. No, that shortcut does not work at all. It's not even a shortcut. It is a detour into a big red sign that says that you cannot do that. All right, the only way you can go from one species to another is to use the mole relationship between them. And to use the mole relationship between them, you have to be in moles. So first thing I'm going to need to do is I need to convert the grams into moles. Then I need to go moles of one substance to moles of the other. Finally, then I can convert. So now, again, the number of arrows, 1, 2, 3, tell me how many steps I'm going to need in my problem. So here we go. I start with the 45 grams of AgNO3. And first thing I have to do is convert the grams into moles. So, and again, from the periodic table, it is always 1 mole. So a common mistake students start to make, or a trap they fall into, is they see the 2 in front of the coefficient and they're like, oh, that means I always use a 2. No, the only time that 2 matters is when you're going from 1 mole from moles to moles. If you're using the periodic table, it's always grams. All right, so I find the molar mass of AgNO3 on the periodic table. So I have 169.88 grams of AgNO3. So that has gotten rid of my grams of AgNO3. So I've taken care of that step. Second thing, I need to go from moles of AgNO3 to moles of ZnBr2. So that is where the 2 and the 1 come in. So now I've got, for every 2 moles of AgNO3 that react, 1 mole of ZnBr2 react. All right, so now I've gotten to that second step. And now my third step is to go back to grams of ZnBr2. Sorry, I dropped the 2 there. And that, again, since I'm using the periodic table, it's always 1 mole of ZnBr2. And so the molar mass of ZnBr2, 225.19 grams. And then I'm writing pretty big, so I'm running a little bit out of room. I need to plug all that into my calculator. So I'm taking the 45. The way I do it, I work from left to right. Some students like to multiply everything across the top and then multiply across the bottom, then divide. I go 45 divided by 169.88, and then divided by 2, and then multiply by 225.19. That way I know I don't miss anything, and I can just do it in one thing in my calculator. So thinking about sig figs, I have 2 sig figs in my beginning number. I have 5 in that number. I have 5 in that number. This one, who cares how many? Well, there's infinite sig figs, I guess, but I don't consider those. So I need 2 in my answer. All right, so here's a tricky one, or I shouldn't say tricky, one that students definitely have problems with. The calculator says 29.8. I need to write that with 2 significant figures. So obviously it's this one and this one, but if I look at that 8 pushes the 9 up to a 30. So, or the 9 up to a 0. But if I just write 30, there's only 1 sig fig. All right, you have 2 ways of doing this. One, you can just write a decimal point after it, and that indicates that that 0 is significant. Or we're just going to go with that way. Actually, I'll show you the other way you could do it. You could write it in scientific notation, but that seems pretty cumbersome to do. So I would just say if you need to indicate that the last 0 on something is significant, put a decimal point after it, and that would indicate that. All right, so that is example 5. So example 6, again, go ahead, stop the video, and then try example 6 on your own. And then when you're ready to check your answer, start the video up again. All right, here we go. So I get 17.09 grams of AgBr. Again, I'm starting with my grams of ZnBr2. So then, again, whenever you're starting with grams, the first thing you have to do is convert it to moles. All right, if you haven't recognized yet, moles are kind of important. They're kind of a big deal. So use moles. So if you're not in moles already, that is your first step. So when in doubt, convert to moles. And then from moles, again, we're always writing the moles below, the grams above. Then once you get into moles, that allows you to move from one part of the equation to the other. All right, you can kind of imagine this like, okay, there's walls up here and you can't go past those walls. But once you get into moles, you can convert from one substance to another. So that first thing I did is to go grams to moles. So that canceled out my grams. Then I can go from moles of ZnBr2 to moles of AgBr. The 1 and the 2 are those coefficients. I know that for every 1 ZnBr2 that react, it produces 2 AgBr. Kind of like in your copper silver lab, you saw that you had that ratio of 1 to 2. For every 1 copper that reacted, it made 2 silvers. So then the moles of AgBr cancel out. Then I can go to grams of AgBr from the periodic table. That's just the molar mass. And then since for sig figs, I have 4 sig figs in this value, I have 5 sig figs in that one. I don't care about sig figs there because they don't apply. I've got 5 sig figs here. So 4 needs to be my correct number of sig figs. It rounds pretty easy this time, 17.09 grams of AgBr. All right, so again, this method of, the number of arrows, you can see we had 1, 2, 3 arrows in this for 1, 2, 3 steps. It's definitely just a scaffolding for you. You're definitely welcome to keep using it, but if you can start to see your way through the problem without it, then it's not something we're going to expect to see on the assessments, but we will expect to see this whole thing and done correctly. So if you're not doing those correctly, make sure you really try to use that scaffolding. And that is how we're doing stoichiometry problems. Yes, Stoich.